Hey, thanks, Karen. Thank you, Karen. And I really mean it. You can unmute and just yell out your question and interrupt me because I'd much rather it be interactive. If you're a little shy to do that, please put it in the chat. And both I, but mostly Karen, will monitor the chat and be the one to stop me and answer the question when you have it. Okay? So today we're talking about geometry for young kids, getting into shape, geometry and spatial reasoning in the early years. So a lot of curricula and lessons that you see, you do a Google search of teachers, uh, uh, pay teachers, uh, emphasize naming shapes. There's nothing wrong with naming shapes. Giving a good vocabulary to them helps communication. It's an important ability in and of itself. However, we want to do naming shapes and more. And we want to do naming shapes right. Here's a girl who clearly didn't quite get the idea what the teacher meant to name these shapes. She named this one Bob, this one Sam, Tedison, Kate, and Harry. Not exactly what the teacher had in mind, but okay, Hope, you gave them your own names. Still in all, what we need to do is go beyond shape naming to really understand shapes in a better way. So many times, naming shapes, the square is always oriented like this, right? The triangles are oriented like this and always kind of are symmetrical, equilateral, or isosceles, if you don't mind that language, and the like. When kids name, they should be naming a shape category. Eventually, as we'll get to in a second, based on the parts of the shapes and or finally the properties of shapes, and I'll explain all that a little later. First, let's just look at two studies that I've been a part of. Mike Batista and I did an early study where we looked at 6 to 12-year-olds and just their identification of shapes. We'd say put a chip on this picture, all the ones that are triangles or squares or rhombuses, etc. And Julie Sarama, who's my wife and colleague, decided years ago to look at hundreds of kids that were younger, 3 to 6. And the first study used the same tasks as used in previous research with older students. So Julie and I had to do that. I know some of you might say really young kids, 3 and 4-year-olds, might be a little confused by the numerals and hey, you didn't hold up shapes like I'm doing over here, making physical shapes. You just gave them pictures. I get it. Still, we wanted to compare. So here are circles, and I'm going to ask you right away to participate here a little bit. Just do this for me. Put in the chat all the numbers of the shapes that are circles. Go ahead. Real quick, just shove it in the chat. Put number space, whatever you want to, or just contribute one. Okay, either I'm not getting the chat. There they come. Okay, good, good, good. Wow, wow, they're going to scroll right out of sight for me. So 2, 7, 12, 14. Okay, 2, 7, 12, 14, 15, and 13 some people named. Let me see if I have any others that I missed. Oh, did I say 5? I think so. 9. Good, good, good. Now stop that for a second um, and put in the chat which ones do you think that kids might get wrong if they were asked to put like a chip, a counter on every circle. Which ones are probably the easiest for kids to get wrong? 10, 11. Yeah, yeah, yeah. This ellipse and this just almost circle kind of 10. Any others? Some people thought 6. They do indeed. Not as many. 6, 10, 11, 6, 10, 11. Oh, 8. Not as much, but we did have a couple kids do that. And indeed, though, the thing is, it's pretty rare. Check check out that for Fours, let me explain fours. We went from 3.5 to 4.5 for fours. Okay, 4.5 to 5.5 for fives, etc. For fours, 92% correct. So they not only found all the circles, but they didn't get any of those not many kids got one wrong by the time their sixes at 99% correct. And mostly incorrect, we're missing one. So we marked it wrong if they missed 15, even though you just might not have seen it at the bottom. The important thing here is in early childhood, probably we don't need to spend like a week on circles or something like that. They know a lot coming in. Okay, let's do the same thing. But first, which one are squares? Go ahead, put in the numbers you think are squares. I know you're putting them in one line, so it takes a while. You got to find each one, type it in, etc.
What's the, oh, never mind.
No, go ahead. Go ahead.
No, I couldn't see the number on the one at the bottom, but
Oh, 13. Yeah, it didn't fit
got it.
in there.
Thank you.
Is it Joy?
Yeah.
Yeah, hi,
Thank
hi
you.
Joy. Yeah.
Thank you.
Okay. Oh, here they come. Here they come. Here they come. 4, 5, 1, 10, 4, 9, 13, 5, 1, 10, right? 9, I have a hard time personally figuring out if this is longer than it is wide, but either way you put it is good with me. 11, 13, good. 8. And then if kids are going to get some wrong, which ones do you think? Switch to wrong. 2? Yeah, 2 is very common. Yep. 3, 2, and 11. Yep. 11, yep. Nobody chose one of the most popular ones wrong. Ah, Beth did. 5, Beth. Absolutely right. Up here, kids say what? What do they say? Anybody want to unmute and tell me what they call this?
A diamond.
Yeah, there we go. Somebody unmuted. Several people put it in chat. Connie, Jeannie, Teresa, thank you all. Yeah. So they pick this as a square sometimes because we call squares equal sides, right? 4 equal sides. So they say, okay, that's it. But then this one is turned, and look at people. I'm getting ahead of myself because I'm trying to do the development first and then later the instruction. But oh my goodness, how many children's books on shape will have this and say this is a square, and this on the very next page and say that's a diamond. So it's understandable that kids say these things. How'd they do? How'd they do? 3s, 4s, and so not quite as well as circles. But 82, 86, and 91% is nothing to laugh at for 3s, 4s, and 5-year-olds, right? So they know something again. Triangles are a little tougher for kids because you probably know the class of triangles really does have different shapes. So instead of doing the right ones, 8, 6, 11, this has a line here if you can't see it, 1. Let's just put in the chat this time, which ones do kids get wrong on triangles? Three? Yeah, that's not as popular as maybe somebody else will name it. 3, 5, 4, 9, 14, 3, 5. 5. 5's a little more they think it's a triangle than 3. So it's funny if the curved sides bow inwards, they go with it more than if they bow outwards. I guess it maybe looks more like a circle to them. What else did you guys say? 3, 7, 9, 14, 3. We're 7. Yep. Not still as popular as 5 and 14, but popular choice of calling it a triangle. 14, 4, 3, 5. I think I got them all. What did we do with 10 and 12? I wonder if Connie pointed out 12. If they called that a triangle, we would just ask them. This is exactly what Mike and I did with the 6 through 12-year-olds. We just ask them, show it to me. And if they'd say, well, there's one here and there's one here, yeah, great, great, full credit. If they said the whole thing's a triangle, then we scored them wrong just because we had done that with the older elementary students. So the kids were a little lower on this, but not low, about 60%, right? Correct? They missed some of the exact ones you guys said, and then sometimes the 12 and 10 had do. And also, did anybody put 4? I don't. Yeah, Virginia did. Um, 4. It's like it's almost a triangle. You just have to. It's just missing this little part. We understand, but we're really going with a mathematics definition of a triangle here. So, last one. Last one. Let's do only again what's wrong. Which ones did they get wrong, if any? So this is rectangles. Go ahead and put in the chat any you think would be easy for kids to get tripped up on a little bit. Two, Kelsey, pretty fast. 2, 2, 3, 5, 7. 2. Yeah, yeah. Squares are and 7, right, are not rectangles because we teach it out of them. I'll get back to that maybe later. Wow, Marisa has a lot. 3, 5, 6, 8, 10, 13, 14. 3, yeah. 5, yeah. 6, yeah. And now I forgot the list again. 8, 10, 13, 14. 8, yeah. 10, yeah. 13, and not as much 13. Too much, I guess, like the famous diamond for them. And Sheila, 10, 13, yep, yep. And a lot of others put in the same thing. Yeah. So you can put it in the chat if you want to. Either confirm, deny what I'm going to say next, or add to it, enhance what I'm going to say next. What's one of the problems with rectangles? Well, first of all, we tend to, in early childhood, and honestly, up into the elementary grades for sure, say we need to teach kids the 4 basic shapes, by which we mean circle, square, rectangle, and triangle, right? Which is why I featured some of those here. And so squares are not rectangles. Rectangles are not squares. Come on, let's get that straight. Squares look like this with 4 equal sides, and rectangles have what? What's the most common, and I will argue, horrifically unmathematical definition that I was taught, that are still in curricula, that are still in books for rectangles? 2 long sides and 2 short sides. Okay, so that would leave out the squares. But squares really are rectangles. They're just a special case of rectangles. Kind of like a terrier is a special case of a dog. It's just got some extra properties. The other thing is 2 long sides and 2 short sides. Well, you guys all pointed out they might pick 6, 10, 13. Hey, even 14 has 2 long sides and 2 short sides because we didn't even say 2 long sides the same length, right? Which would help, but that would still include 6 and 10 and the like. And so I pressed a key, clicked without meaning to, but kids were lower on this because of those kind of things. Interestingly, to me at least, 4-year-olds were more likely to accept the squares than 5 or 6-year-olds. Isn't that interesting? We haven't taught it out of them yet. And mathematicians would say, people, and you can argue with me in the chat or unmute and give me a hot argument that there are no 4 basic shapes. It's a historical argument of curriculum and education in the United States that we do that. Other countries don't do that. East Asian countries, for example, they learn four-sided shape first. And I think every shape on here would be a four-sided shape. And then next they learn four-sided shape with all right angles. Now you got rectangles. And people, they don't learn that as a definition. They're lucky enough that the East Asian languages, four-sided shape is the name of this group of shapes. Four-sided shapes, all right angles is literally the name. We do rectangle and triangle and, oh gosh, ellipse and all this stuff that don't give a clue. But they also start with the general case and then they make a special case. And so the square is rectangle with all equal sides, right? So it's built into their language, it's built into the culture. It's something we need to kind of undo. So I told you there were two studies. I just wanted to show you just for fun. These are the data we just saw for 4s, 5s, and 6-year-olds. Here is Mike and my data for 6 through 12-year-olds. If you look at this, I think you see two things pretty clearly, right? Number one is they come in at the youngest age knowing something about shapes. Even rectangles, the hardest one of them all. Secondly, they don't learn very much during elementary school. We can do so much better at all the grades than this, right? I'd hate to be a principal and show this graph to parents and say, look at what we taught your kids about rectangles over 6 years. Wait a minute, you only went up like one extra rectangle at the end, just not a stupendous thing. Here's the same thing for triangles. They learn a little bit more, but it's not impressive because this is what kids see, right? Hey, our son brought this home in 2nd grade. I guess to its credit, this so-called worksheet kind of thing had a triangle that didn't have a horizontal base. Like I told you before, most all books and presentations, no matter how they do the triangle, here or like this, it's got a horizontal base. Here it doesn't, but that's typical for what it is, right? A pennant there. Still in all, our kid got 100% on this, but look what the publisher did. They like to give an example of ring the shape that has the shape of a triangle, so they put a dotted line around it and you fill it in and then you get what the task is, right? It's got a hook on it. Okay? Listen, I don't want to be like mathematicians are all, want to catch anybody in mistakes. And no. But mathematics as a discipline is about precision and logical thinking. Mathematics at its core is about learning precision and logical thinking. This is just sloppy. And it's not the kid's fault, right? Son got a star. So what's wrong with the musical triangle? It isn't actually the usual musical triangle, which has a hole in it, right? A gap. But it also has curved corners. And he got full credit for this sailboat, but maybe he was looking at these triangular sails. But what he circled has 1, 2, 3, 4, 5 sides, right? It's a pentagon. We got to get rid of stuff like that. It does not help kids learn. In fact, kids would be better off not to come to school if that's the sheet they're supposed to fill out, right? This is why from early childhood education all the way up to high school, traditional instruction in geometry actually fosters little conceptual change. In this study by Rich Lear and his colleagues, first graders were followed from 1st grade, same kids when they're in 2nd grade, same kids 3rd grade, given the same task. How would you tell that this shape is different from this shape? How would you describe it? 1st graders were more likely to count the number of sides and angles in first grade than they were in third. Once again, just like squares are not rectangles, the misconception. We teach certain geometry concepts out of kids as they go through school. So we need to do better because the effects of this kind of neglect appear on student achievement. The TIMSS study, the PISA international studies, the lowest area is geometry. And even among preschoolers, researchers have found that there's a big gap between what, in this case, Chinese preschoolers knew and American preschoolers, because we don't have cultural supports, and most of us went through a pretty bad geometry education ourselves, and they can do so much more. Little redhead here, listen to him. This is a teacher's aid. We wanted to just get some videos for our website that I'll try to share with you later if I haven't already. She's a teacher's aide. The teacher was sick, so she said, I'll play with the kids in shapes, and we thanked her, but she did, she never had tried this before, so you see she's kind of amazed by what this little 3-year-old does. Take a look.
Here yesterday, but we're going to play a shape game. Okay, I'm going to have you pick 2 shapes.
I like parallelogram and triangle. Rhombus and triangle.
All right.
There's circles and hexagons and octagons too.
Okay.
Parallel.
I want a parallelogram. And you saw the teacher's aide look at the person running the camera and say, whoa. And then, you've got pentagons and octagons too. At 3 years of age, we often limit vocabulary and concepts with young kids in math because we think we didn't know that stuff till I was in middle school or something. Come on. But it's not a limitation in kids' learning or interest, right? It's a limitation in our memories of what kids are possible, what kids can achieve possibly. So geometry needs to move beyond this basic shape naming that we talked about, along a learning trajectory, which I'll get to in a minute, to learn about the parts of shapes, shapes' attributes, analyzing shapes, describing them. That's what makes it so powerful. If you do these things, building mental images and transformations of shapes, expanding them and other things, and then decomposing and composing shapes. In other words, a simple case. Oh boy. There we go. This isn't a very good case, but 2 rectangles. Oh shoot, I thought they were the same length, but they're not. So 2 squares together will make a rectangle and other kind of transformations. This is very simple. Most kids get that, but there are so many more interesting things for us to do with kids on composing and decomposing, and it's really important. Composing and decomposing is, and in geometry in general, is really helpful to kids. Look at this study that came out, let's see, what's 2023, right? Doing geometry well with kids built up executive function, working memory, cognitive flexibility, inhibitory, and also they monitored and controlled their ideas and their actions. And they found these changes were permanent. In other words, they went back later and kids were still higher in all those things. Here's another one. It increased kids' creativity. And you might say, creativity, are you kidding me? Math, creativity, all I remember is filling out worksheets and being stressed. Yeah. High quality math does develop creativity. Look at this study. If first graders did tangram puzzles it increased their creativity. And I don't know if anybody knows any more about the famous Torrance test of creative thinking. There's a figural test and a verbal test. The figural test, you could figure out, yeah, I can see why doing tangram puzzles would help you with figural creativity in a way. It also increased their verbal creativity. Something's happening when kids do high quality geometry underneath the surface in really interesting ways. Okay, so a couple of researchers started Julie and me off on developing our learning trajectory. This is 30 or 40 years old, but it still stands. We've modified it. People have added to it for sure. But I wanted to give you an idea of the broad categories of levels of thinking, and then we can look at more at particular details. What the Van Hillis said is the first broad level, which lasts for 5 or 10 years, depending on educational experience, is the visual level. That is, let's take a look at some objects here, right? Like kids at the visual level would say it's a rectangle. Why? Because it looks like a door, right? That's visual level of thinking. Whereas, let's take a look at a picture of a door, but at a perspective, and then that shape that's the outline of that, right? Looks like an iPhone outline to me, and then there's these kind of things. So what would visual thinkers say? Young visual thinkers, but young can mean, like I say, depending on experience, going far up. Which, at first in the visual level, all on the top row would be rectangles. These are all rectangles. They all look like rectangles. Why is this a rectangle and this a rectangle? Because it just looks like a door. You're just standing at the side. No differentiation between a representation of a real world object and the geometry of what's on the page, right? Now on the bottom one, no. That's tilted. If you turned it, it would be a rectangle. This one, too skinny. And that one, well, squares aren't rectangles for sure. Later in the visual level, how did they develop from there then? Let's take a look at that. A visual thinker does develop. So then they'd say, nope, that's not a rectangle. Doesn't look right. That's not a rectangle. Well, maybe it is. Maybe, just not sure on that one. This is a rectangle. They develop flexibility in their thinking. Yeah, this is a rectangle. I just turned my head like that. Probably. Some kids, yes. Some kids, no. Even at the visual level. Definitely not the square still. Then they develop into parts thinkers. Okay? Now they're thinking the parts of shapes. This isn't a rectangle because it doesn't have all those features. You know, it's too slanty. This isn't a rectangle. It doesn't have corners. It doesn't have corners, but I meant it doesn't have angles. A right angle is defined as two straight lines that come to a point, which is another reason that musical triangles, you know, with their curved there's not two straight lines that come to one point. Okay, how about the rest? Well, yeah, that was a rectangle. That one's a rectangle. Still not the square, right? And how about this one? No, because even though you and I know there's not 4 straight lines, if we just say 4 sides and don't help kids understand that what we mean is 4 straight sides, they will often say that is a rectangle. What do we do then? We really want to develop kids' ideas of different shapes by providing them with a much richer experience with different shapes than, like I say, I hate to keep saying it, that we hold up this and say it's a square, and we hold up this and say it's a triangle, and we're done, right? Instead, we want kids to see all kinds of different shapes. So this is Julie and my shape set. There are other shape sets too you can use. As the main message isn't use this set, it's use a variety of shapes. So here in our shape set, you have all the pattern blocks. These are, you guys know these things. They are great for composition, decomposition, and shape. Not so good for learning about shape classes because every triangle is an equilateral triangle. Whoops, so sorry. I want to go back here. What else? The tangram shapes, the famous Chinese puzzle shapes. Now that gets into different shapes like the parallelogram down here. And then we have, like I showed you before, physically, we have different rectangles of different proportions, skinnier and the like. We've got triangles that are, oh, whoa, look at those angles. A lot of kids will reject this as a triangle at first. Here's some skinny rectangles here. And then a lot of divergence, okay? So do you see this shape right there? Why is that in there? Well, that's what I'd like you to do for a minute on the slide right after this, okay? We'll come back to that shape set. First, I want to say, so what do we do with the shape set? We first explore and match. So in our shape set, which you can see pictured and you can see here in this bag, the blue shapes and the yellow shapes are identical. So all shapes are in both colors, so kids can just have fun matching them and stuff like that. Sorting them, matching them, making designs and pictures and everything, and then eventually really doing serious shape composition, which comes later but is really important. So here's what I'd like to do. You can unmute. I love when people unmute, but again, if you just don't feel like it, would you kindly put in the chat any shape that you say one of two things. I don't know what to call this one, or why is this shape in there? That's why I pointed out this Z6 in there. It seems like such an odd shape to be in there. Why is that there? Okay, so let you look at them, and put any letter, or letter and numbers because we ran out of letters in the shape set, into the chat, and I will try to justify it. And if you want to put the letter and a question about it, or you could just put the letter for me to talk more about that. Okay, lots. Hold off for a minute putting more in, or these are going to scroll out of my sight. Okay, so let me do these, and then any I didn't get to, please tell me. Oh, where were we? Where did this start? About 3:33. So Z13. Let me start with Joy there. Z13. Ah, good one. Why? The first question is, what the heck is it? It's called a deltoid. Informally, if anybody works out with weights and you work your deltoids, that's the shape of the muscle in your shoulder, right, like this. So that's one reason it's informally called a deltoid. Mathematicians actually call it that, so it's helpful that they do. But it's why, first of all, how's it defined? It's defined as a four-sided shape with two adjacent, not opposite like rectangles and parallelogram, two adjacent or connected sides that are the same length, and two other connected sides the same length, but a concave angle. So this goes into the shape, okay? And before I say why we do it, I wanted to introduce another one. Where is it in the diagram there? Well, you can see it up here. Z7 there. This one also is defined very similarly. See Z7 if you can't see what I'm holding up here very well. But two adjacent sides the same length, two other adjacent sides the same length, but all convex angles. No angle going into the inside of it. And hey, this is one of the few that mathematicians call it a name that I know. Kite. They call this a kite, and it's defined as that. So why do we teach kids deltoid? Yeah, if they're interested. That little redhead kid in the video, I would teach them that in a second. Other kids, I'm not going to worry if they don't know deltoid. Then why do I do it in there? Because we play games, and I might get to this if we have time today, called Is It or Not, where the teacher will usually on a whiteboard, so you can erase it because it makes it a lot more flexible, but you can use the shapes on it too, physical shapes on it too. We'll say, is it or not? Is that a triangle? And I always do this lesson like my wife and colleague Julie does it as a game show, Is it or not? You guess, and you have the kids think, pair, share. Yes. Why is this a triangle? Well, it has 3 sides and 3 corners, or 3 angles. So this one's included partially because adults will call this a triangle. So because if you draw an outline around it, of course, it's triangular in nature. But the kids very quickly pick up, no, it looks like a triangle, but it's got 1, 2, 3, 4 sides. That's a parts thinker, just like we were talking about before. And this is preschoolers and above, for sure. I mean, kindergarten, first and second graders usually need to start the same place preschoolers need to start because they haven't gotten a lot of this rich geometry before. So we call them foolers because those are very close in the is it or not activity. Here's another is it or not fooler, right? Again, with 4 sides because this part is quote unquote cut off and 4 angles. So we don't start with the hardest foolers, but we want them there so kids really learn to think with precision and logic from the definition of rectangle that we don't give them. They come up with the definitions, and then we just help them build that description with mathematical vocabulary. Okay, I promise not to talk about all the other ones at that much length. How about Z6 and Z7, Anna? Z6. Beautiful, beautiful. Why is it in there? It just looks like, oh, come on, that's not that attractive a shape. I dropped it. 1 second. I got it. Okay, here's Z6 again. 2 reasons I can say that this is important to include. Number 1 is that boy said pentagons, and he probably meant this one, right? That you can see on the diagram is Z11 there, if that's what you prefer looking at, Z11. And that's great, it is a pentagon, but it's a special pentagon. Pentagon, this is the trouble with English compared to the East Asian languages, right? Gon actually means angle. So pentagon means 5 angles. Other things like equilateral, equal sides. Geez. English comes from so many sources that we have so much different, complex and sometimes difficult vocabulary. Anyway, back to my point. We want them to know this is a 5-sided shape, but we also want them to know you can have a 5-sided shape, 1, 2, 3, 4, 5, that looks very differently, right? So that's one reason. Here's another reason. Once we start learning about properties, that's past parts, and on to a new level of thinking. Okay, let me finish my example, then I'll return to that to make sure I'm clear on that. Once we do it on properties like a right angle, then we really, really want them to see that right angles aren't just in figures like this, or, of course, the famous square, right? Right angles can be one right angle on a shape. And it's harder to see on this shape than it is on the others, but that really helps them know about right angles. And I often get this question, and I'll get back to the other one. Sorry, taking too long with this. Do we teach them right angle? How do you teach them right angle? That must be really hard. They don't know degrees. They don't know No. Right angles are all around us. In back of me, you see windows, you see panes, you see right angles. You see them on many a ceiling and everything else. So if you just talk to kids about right angles like this with our right angle checker, or use a piece of paper or something like that, they come up, they get it. They get it. That one's a right angle, that one's not. We don't teach them more about angle measure. But how do you differentiate between, and I think I want to jump around now for just a second, sorry. How do you differentiate between 10 and 6 and 12 if you don't know right angles, right? So people say it's too hard, but they want kids to know what a right angle is, but then you can't, how do you talk about it, right? So that's why that's so important. Let's see, what else? Z7, did I do that? Z13, so Z7, yeah, we talked about that. I hope to your satisfaction. Put in more questions. Z13 we covered. Z11, yeah, that's in there just because when we sort the shapes by number of sides, it's just less fun to sort them into piles of 3 and 4. Important categories, the quadrilaterals, 4-sided shapes, and the triangles, 3-sided shapes, of course. But it's fun to have something with 8 angles or sides, with 5 angles or sides, with a different 5, and the like. Z12. I am not as good at scanning this as I should. I don't even, yep. There's the 8-sided shape, right? Important there too, because this is a stop sign, but a lot of people call the stop sign a hexagon, like F up here. But nope, it's an octagon. It actually has 8 sides. So good questions, and yeah, I think I covered them. But come back at me if you want to, if you've got other kind of things. One of the handouts, Karen, if you're there and can unmute, do they automatically see the handouts? Have they already been given a URL for the handouts?
The handouts were sent with the reminder email yesterday afternoon and again this morning.
Beautiful. Okay, so teachers ask Julie and me to do this handout, which it just tries to summarize a lot of what I said. Like, what do you say about rectangles? Well, you can say 4 straight sides, 4 right angles, opposite sides same length, and if all the sides are the same length, it's also a square and all. What do you not want to say? 2 long sides and 2 short sides for the reason we said before. Oh, and that's what I was going to say. Doug is jumping around again. 2 long sides and 2 short sides. We talked about the parallelograms have it, but don't have right angles. We didn't talk about the deltoid down here, 11. That has 2 long sides and 2 short sides. Even if you say 2 long sides the same length and 2 short sides the same length, this would be a rectangle. Nope. 4? Nope. Right? But our definitions, our descriptions to kids are often so faulty that it's hard for them to make sense of it then, Okay, please unmute or put questions, concerns, disagreements too. With Julie and I sometimes have little bits of difficulty with people who say squares are not rectangles. I didn't get that from you guys, but if you're feeling that way, I hope we could talk about it even more, because it's a sticking point for some. But right now I'm going to go on and talk about not only geometry, but spatial sense then a little bit. Okay, just a fun example. Not an activity for kids. I'm just talking about spatial sense in general. I think you could see from these 2 pictures of the table that one of them's longer and skinnier, and one of them's not quite as long and a little less skinny, right? what's interesting, and the reason I'm presenting this is not for kids, not even for education, other than we have to remember that optical illusions can really fool us about geometric things. Let me show you this, why I put this picture up, right? I'm going to draw an outline of this table here. I'm not going to draw it, I've drawn it, but I'm going to show it to you. And then I am not going to change the shape of that thing one little bit, okay? I'm just going to move it. So watch when I move it. Whoa. The darn thing fits exactly on the other table. Again, here. You ready? Watch it. Yep. Our knowledge of tables and the way they usually look and our experience with it interprets this perspective as being long and skinny and this one, but they're not. They're not actually on the slide any different, those two parallelograms that represent rectangles in real world tables and stuff. So spatial thinking is complex, it's interesting. Let me do this. Can you write no in the chat real quick if you don't have a paper and a pencil you can quickly grab? If there's too many people that find it inconvenient or impossible to get a paper and pencil, I'm going to skip this activity, otherwise I'll do it. Okay, hopefully everybody's got something. So see if you can draw a triangle with at least one right angle. Can you draw did I say triangle? I'm so sorry, people. A trapezoid with at least one right angle. So a trapezoid is defined as a four-sided shape, a quadrilateral, that has two sides opposite and parallel, right? Not necessarily the same length, just parallel. And the other two sides are not parallel. So just fool around with that for a sec. And I think I'll once again go back to the shape set. So I hope you saw, actually this isn't going to be the right thing. Here's a trapezoid without a right angle, right? So actually where I want to go is way back to the ones we were talking about before here. This has a good example of a trapezoid. It's not a rectangle because these two sides aren't equal or parallel with two right angles. And if you were following me, you can't make a trapezoid with just one right angle because then it wouldn't be a trapezoid. If you slide this over, then that's not a right angle anymore, etc. So these are not for little kids, okay? I'm just talking and fooling around with you guys on it. So that's not a challenge for little kids. See if I can, I'm not going to do that. Oh, this one's so hard. So hard. This challenges adults everywhere. Give it a try. If you got your pen and pencil, and comments, again, in the chat on these activities, and or unmute are very welcome as always. But draw a horizontal line first. Just a line segment, actually, right? And then, now assume that horizontal line is the diagonal of a rectangle. Can you draw the rectangle? So I'm going to struggle with this myself here too, while you fool around with it, and let's see what we come up with. So first a horizontal line, then you got to say, okay, that's the that goes from one corner to the opposite corner of a rectangle. How am I going to make that rectangle, right? So fool with it for a little bit. So that's my attempt. I first drew that dotted line and said, okay, how do I make a rectangle around that? And I don't know about you, but I have to turn the paper and then draw the rest of the rectangle because it's hard. This is spatial and geometric kind of challenges that are difficult. And why? Well, we're at higher levels, but this early visual levels, that we don't leave them and forget them. People at the higher descriptive levels still revert to the early visual levels, at least I do in a task like that, like those two. Okay, a little more on parts and properties. Remember I mentioned that parts are parts and properties is a higher level of thinking? Let me explain. So when you just recognize a rectangle because it looks like a door, you're at that visual level. When you understand that it's a rectangle partially because it has 4 sides, you're at the parts level. You can count the parts, but you're just looking at the parts, the sides, and maybe the corners. But if you learn that a rectangle has to have right angles, what are you doing? You're taking the two sides of that and putting them into a relationship like this. Of course, you know it as perpendicularity or a right angle. You have to relate the two. A simpler example is, how about squares have all equal sides? How many sides is parts? It's got 4 sides. Great, you count them. Equal means you have to put this length in relationship to this one, and this one. So that's a property, a relationship between parts. The visual level is just as a global visual. Parts means I can identify parts and count them. And properties means I can relate parts. These 2 sides are equal. These 2 sides are parallel. Or these 2 sides form that kind of angle. So that's where we try to go.
Square.
And I love the way that this preschool teacher, I will stop it and go back to it, Lucinda, she deals with parts and properties in an informal way with these preschoolers. First time the kids have done this activity with her. And what she does, I love this activity. We call it shape step. And she put using frog tape or painter's tape, that doesn't stick to doesn't leave glue on the rug. It sticks gently, but it doesn't leave glue. And she made a whole bunch of shapes. She didn't make as many that I would like to see, a variety of shapes for this activity, but hey, it's the kids' first time doing it. And then she'll yell out the name of a shape and they have to get inside that shape. Let's take a look.
Square. Okay. Is everybody in a square? Are you sure? Drew, are you in a square? How do you know? 4 what? 4 sides. Are all the sides the same length, Drew? They are. And what are the corners like? Are they square corners? They are. All of you are in square. Very nice.
Now rectangles.
Find rectangles.
Watch how she deals with the relationship
Okay.
between squares and
Once you
rectangles.
found your shape, stay in it, okay? Savannah, where are you going, sweetheart? Rectangle. Find one. Alrighty, is everybody in a rectangle right now? Yes. Are you in a rectangle? You are? How do you know? It is a special one. How do you know it's a rectangle though, first of all? It has 4 sides, and what are the corners like? What kind of corners? Square corners, and this one just happens to have all of its sides be the same, right? So what do we call this special rectangle? A square. Oh, you're so smart. All right, one more time.
This is her
Medium.
modifying Julia my activity. Medium level, fast speed.
Ready, go.
She puts so many concepts into this lesson we never even thought of. We learn so much from teachers.
Square.
And on it goes. Okay? So they continue. I just wanted to show you that because I really do think that our work with teachers have given us our best activities, because they'll do things that we would have never thought of when we're concentrating on that kind of mathematics. So I love that she does that. Sometimes they're at a low level and slow. Sometimes they're at a high level and fast or medium. And so all these concepts and then the shape concepts in between. And I hope you saw, she asked them about the parts of shapes and count them. And then she pushed them. And these kids haven't mastered that. She's guiding them closely. Again, first time they did this activity, they're just learning this stuff into relating the property, which is equal size and right angles, the property of one side in orientation to the next. So cool. Thank you. Thank you for a question. Oh, Joy, I'm glad you thought it was fun. It really is great. And you could do it outside if you want to, in chalk and good weather. And again, the painters or frog tape is a great way to do it inside. And then a question at the beginning, should we encourage children to call a ball a sphere? Beautiful question. I wasn't even going to do 3D because of time, but we always ask the kids first what they would call it and how they describe it. So I hope my attention to vocabulary and correct vocabulary did not give the misimpression that we start by teaching them the vocabulary and we start by teaching them a definition. I hope I made it clear. No. The first names, identify the shape, comes from the kids. And the first descriptions come from them describing. And then we work with them, because sometimes kids talk to each other, disagree, and then eventually we supplement their language with other things. So, for instance, and pretend they call this a diamond. Very common kind of thing. Incidentally, though, if you look at a dictionary picture of diamond, you'll often get this, the kite. Again, mathematicians actually call this one a kite. And because they'll have a jewel of that shape, but there's not 4 equal sides. So when kids call this a diamond, we say yes. You want to know what mathematicians call it when it's all equal sides? They call it a rhombus. And usually our software, by the way, that we created, always called it rhombus, and kids picked up on that right away. They love rolling the R's. That's a rhombus. And so when they adapt that, because they like that. Okay, I knew it was as a diamond, but I like the word rhombus, And so we just reintroduce that and name it too. So how about the 3D that you are bringing up in your question? We actually allow them to call it a ball, and we add the vocabulary sphere in the same way as I just said about diamond and rhombus. But is it acceptable if they call it a circle? We would probably say, they don't often, they usually go with ball right away. most kids. But sure, they could say circle, and I don't have one here. I want to hold it up, but I can't. Um, uh, we would say, yeah, the outline of this, like this, what you see, a silhouette or a shadow of it or anything else is a circle, but this is a solid shape, not a flat shape. So we call this a sphere. You might call it a ball. Mathematicians call it a sphere. So we take circle, we don't say no, we say, yeah, that's what it looks like, and if you drew a picture of it, the picture would look like a circle around the picture. But mathematicians call solid shapes, not these flat shapes, that word. Disagree or ask me for more in the chat if you like. Now I'm going to I said earlier that good, high quality math teaches language, vocabulary, logical thinking, executive function. Maybe you call it self regulation, but it's that whole idea of cognitive flexibility is one of them. Like, can you switch what you were thinking to a new way of thinking? Working memory, all the ideas you had there, and a response inhibition is don't right away go for the first answer you think of. All those, I hope you see, and geometry are involved in this game called Guess My Rule. So you see the directions there. I don't know if I've given you time to scan them, but we're going to do it anyway. I'm going to do it on a screen. We don't do it on screens with kids, right? I taught kindergarten and preschool in my school experience when I was a teacher. And usually I would have them on a rug in a nice circle. And then I actually, if you know Unifix cubes, they're those connecting cubes. I actually did it a certain way. You don't have to. You could just put some in a pile here, some in a pile in here, and have kids count. Point to which one they think the shape goes on, because it's a game where they have to guess. We also call it read my mind. They have to guess what I'm sorting by as I put the shapes out and figure out my rule for sorting. Okay, read my mind to figure it out. And so one thing I did that worked well for me is I put a big piece of white construction paper, a big piece of black construction paper, and then they had one Unifix cube white and one Unifix cube black on each of finger of two hands, and they would hide it, and then I would say, okay, here's another shape. Here's another shape. Which pile does it go with? And I would say go, and they would hold up the thing, so they're not just copying what anybody else is pointing at. It helped me in kindergarten. You do it the way you want to, but let's try it. So on this example, you always put like 2 or 3 shapes out to start with. So I'm faking that up on the screen here, that I put a bunch of shapes here and a bunch of shapes there. Then you hold one up and you say, now I would say black or white, or you would say here or there. For now, I'm going to say up or down. Does it go up or down? Now all of you can see, okay, that one's down. And then you keep going. And believe me, when you do it as simple as squares and triangles, the kids pick up the game very quickly. And then you want to move to other games. I'm going to jump not to a slightly harder preschool game. I'm going to jump to adult games, because I really want you to feel what kids feel as they're engaged in this guess my rule or read my mind kind of activity. You ready? So here's one. And I'm not asking you to guess until I put out enough to give you an idea. I'm not putting out very much. So now what I'd like you to do, get ready at your computer. Just put U or D, up or down, right? That's it. Everybody, just put up or down for this one. We're going to go pretty fast, so get ready to just put Okay, up, 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 up. And I'm going to just move on, people. So if you don't get yours in, sorry. But I didn't want it to go too long. Here's another one. Up or down. Go. Down, 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 down. Laura's spelling the whole thing out. Very literate, Laura. You could just use the letter if you want to. Yep. Okay. How about this one? Up or down? Up, down. Up, up, down, 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 up, down. Okay. Once I show you where it goes, then, according to my rule, you have to have cognitive flexibility to look at the shapes and say, oh, okay, I had a good rule. It was working. It just didn't happen to be the teacher's rule, right? So there we go. But up would have made sense with another rule. So let's keep going. What's the next one? Okay, up or down, everybody. Up, down, up, up, down, 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 up again. Okay, let's look. Down. Geez. Okay. How about this next one? Up or down? What do you say? Up, 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 up. More ups, but downs. 2 downs, 3 downs, and up is correct. So, oh, I got a few more. I'm going to just do these, okay, to move things along. Ooh, that was a maybe hard one. Let's do this one, up or down. Go ahead, type. Up, down, 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 up, down, down, up. So we still have a difference of opinion what the rule is. Here we go. It goes up, and this one goes down, and then here we go. Anybody who wants to, everybody if you want to, what rule do you think I was following? Maybe not the one you had in mind, but what rule do you think would actually put all those shapes down and all the shapes at the top up? There you go. Connie's and Beth and Kristen are the first ones. Dynamite, guys. 4 sides. 4 sides go up and others go down is a good way to express it, Connie. Kristen, Lee, Andrea. Yep. Several others. It can't follow all the names. Joy and others. Right. So I hope you felt when you said up, but we went down. I hope you saw that you have to do response inhibition. On the next one, I'm going to have to think that. And especially cognitive flexibility. Like, it's hard for people, once they have a good idea that's working for them, to push that idea aside and say, I have to think of something else. It's hard for adults to do this. And that's why these games are so rich for young children. Now, this is one I would do in preschool. I wouldn't do it as the first Guess My Rule game by far, by any stretch of the imagination. But I could get to this in preschool and definitely in kindergarten and the primary grades, right? But not all of these are for preschool. Some of these are even harder. So let's take a look at a different one. Up or down so far? Up, 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 up. Okay, pretty well everybody agrees. Okay, how about that one? Down, down, one person up, down, down, another person up, up, down, down. Most people down, and that's what I was thinking. Once again, another thing I love about this game, people, is those people who put up for this shape were not wrong. So, it's not correct or incorrect. It's, did you happen to guess the rule that I was using? Or were you thinking of a different rule? And think pair share discussions in whole class or small group discussions can get into that. The teacher can absolutely say, what were you thinking before? Oh, yeah, you were right up to the point this one came down, et cetera, et cetera. Talking about those things is good. So up or down on this one? Down, 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 down. Okay, people seem to. How about that one? Up or down on that one? Down, 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 up. Ooh, Kendall, down, Lee, down, down, up. Okay, yes, son of a gun. So all you people that thought that it was rectangles or squares versus other shapes, or four-sided versus other, you were right up to this point. Again, how do you think about it now? Ooh, Kristen, you're giving it away there, Beth and Joy. You are right. The rule that I was thinking of is at least one right angle. That goes up, that goes down, that goes down. Ah, hard to see. Is that got a right angle or no? No. But look at this one. A lot of kids will say down. A lot of adults will say down, I should say. But look at right there is a right angle, right? So cool, everybody. Let me see what how are we doing on time? I am not doing as good as I should. So I'm going to skip the next couple of Guess My Rules so I can get to some other things. This, though, this game is inductive and deductive reasoning par excellence, right? From many examples, induce a rule, right? And the deductive is from a definition or rule, determine if an item has an example of it, and that's shape set. So we do both inductive and deductive reasoning in a really nice way with these games early in kids' development. So the kind of last big topic I want to do with you guys is what I said before, composing geometric shapes, putting shapes together to make a new shape. Not just glomming them together, but what we tell kids is, can you put these together with full size touching? So sure, kids are going to do this early on, but what we're going for is, can they compose this shape into a different shape, like that. So let's take a look.
You pick some of these pieces to put on there to fill in the puzzle.
So she's doing she did this puzzle and this was what she said. Then he gave her another puzzle very similar. I hope you can see it on your screen, but she put a, don't worry about what they're saying if you don't mind. She put a trapezoid on a rhombus and then a trapezoid on the other rhombus.
You do more.
He has to encourage her to do more now, a square on top of a rectangle.
And can you keep going? Okay.
Okay. So she's at a very, it doesn't look very much like what she did on this one, right? So we're pretty confident she's at a level that is our earliest level of development, what we call separate shapes actor foundations. You almost want to say, look, okay, I will confess to you, we originally weren't as asset-based as we hope all learning trajectories are. So we called it pre-composer. And that was true, she wasn't composing. We renamed it because to be asset-based, you have to say, no, she's not pre-anything. She might not have these later skills, but she's got some ideas. What? She's got one-to-one correspondence between shapes that she sees and shapes she puts down there. More important, probably, for her geometric appreciation of her geometric, is she sees some symmetry there. She sees that this ear and this ear and this foot and this foot are the same. She puts the same shape on them, right? So recognition of symmetry is a deep and interesting idea. She, though, does not seem to get yet the idea that these should be the same as the outline. So it's a early level of development. Let's go up 2 levels. I don't have time to show you all 6 or 7. let's go 2 levels to what we call the picture maker level. Let me explain because it goes fast. She's trying to put this square into the arm where you and I can see that only like a blue rhombus of this pattern block set or 2 green triangles are going to fit, right? At this level, she sees side length, it matches that, but she does not yet see angles the way you and I would, okay? So what happens to her? Ready? Ready? She tries to put that square into place, but then she knocks the other 2 shapes in the arm. So she puts them back and tries to force the square into place. It doesn't work for her. So she puts it down. Lucky for her, right next to her hand is a blue rhombus. And she finishes the whole puzzle successfully and completely. But so very different from this little girl. However, still not with shape composition, not with anticipatory thinking, but rather with trial and error. But good for her. Good for her. She completed the whole puzzle, right? Okay, how about where do we go from there? I'm jumping up again 2 levels, people, to our goal for the end of preschool, and if not for the end of kindergarten, and heck, for first and second graders if they're not there yet, right? The goals are always based on higher levels of thinking from where the kids are. So watch the, to me, astounding differences between this 4-year-old and the previous 4-year-old. Ready? So first she puts down one shape and then explicitly the same shape on the other side. So she's using symmetry very, very well and very conscientiously. Secondly, right, she never makes a mistake, which is important. Look at her look at the picture and then look at the shapes. She always picks one that's correct. And then the most astounding thing to me, there we go. Oh, that goes so fast. I'm wondering if I could just whoop. No, I can't, apparently. There we go. Let me grab this. Watch here how long she spends looking at the shapes and where her eyes go. When she picks up a shape, where is she looking? Not at the shape. She's looking at the puzzle. People, watch her. Her mind directs her hand. One more. Look at that. She looks at the puzzle and her hand turns and places the shape because she has built the ability to build, maintain, and manipulate images of the shape, and that directs her hand. She's looking at the puzzle and the shape just magically, to me, but it's not magic, it's great mathematical and spatial thinking, turns the shape into the right position. So let's move on to instruction. This is what I was given. I was given this kit. It had the pattern blocks that I showed you before when I started kindergarten. And then each one of these, this is the teacher's copy to show you, but each one of these, like the duck, was a 8.5 by 11 sheet for the kids to put the pattern blocks on, right? So what level of thinking would these teach? Would it teach that first girl? Yeah, it'd be okay for her, because then she can learn to match the shapes to this. How about the second girl? Well, wait a minute. If all the shapes are already in the outline, the second girl wouldn't learn anything. She would just put the shapes in the outline. And then the third girl, no way, it's not going to be a challenge. So I quickly realized that although this was okay for the kids at their very beginning of understanding shape matching, it did not teach anything about shape composition. And people, these are all the puzzles. The kit I got, every puzzle had all the shapes. And I don't know how much the authors of this didn't respect teachers, but are you serious? You had to show me what color shapes fit on each of those shapes? Like, I wouldn't understand it myself. It just horrible. You know, instead, we have shapes at different levels. And in fact, when I'm teaching a small group, when one kid finishes a shape at a given level, if that was just right, challenging but achievable for that kid, I give them another one at that level, or let them choose from several at that level. But if another child across the table is struggling a lot, I would give him a choice of a puzzle that does an earlier level so they succeed. What do I mean? Which levels? For the first girl, like I said, we want her to be able to match shapes, so let's give her all the guidelines. And she just completes the puzzle by matching. The second girl, well, once she puts a triangle right here, it's pretty easy to see that a hexagon fills this in. So it's scaffolded, but it's still a challenging task for that second girl. And the third girl might get one where, oh, you got to look at the angles here. You got to be careful about how you do this, and you got to fill much more amorphous shapes. So online, similarly,
Hexagon.
kids who are just starting
Rhombus.
would get, this would be the second
Rhombus.
girl right here.
If you want to remove all the shapes, click this.
Okay, enough for that. It's just an illustration of the kind of thing. But the first girl, again, whoop, there we go, would get tasks like this. The second girl, tasks like this, where she has to fill in a larger shape. And the third girl, a task like that would be really kind of difficult task. And then we always stress creativity. So another thing we do is we provide, both with physical shapes, of course, and also online, create a scene. I love this one. A 3-year-old created this scene. Okay, this isn't very sophisticated shape composition, but I just love that she gave this little kid a balloon over here. You know, kids are so cool. And I have to wind things down. So I wanted to show you a little bit of research. When kids in one study did tasks like this, in other words, they would be given first this at a lower level, they'd be given this and asked which of these shapes this makes. Can you see that? Can you see this one together would make this? But then they would be given harder ones. What do these two shapes make? They're the same, obviously. They're for you to see that then this is harder than that one and that one. And this one is the hardest when you put those together, that it would make this. But when they did tasks like this along the learning trajectory of challenging levels, guess what? They substantially improved in arithmetic. They were better on missing add-in problems like 3 plus what equals 8 because they saw the part, and how it made a whole. And part, whole thinking actually transferred to numerical part, whole thinking. People, geometry should not be neglected, even if number and arithmetic and all are the most important topics. Geometry and spatial thinking are just as important, because if they see that 10 ones are grouped to form 110 in place value, they will see that better if they've also seen 4 triangles can be put together to make 1 triangle, and the like. Way later in their development, if they want to really understand that area of a rectangle is length times width, it helps them a heck of a lot to see how you can compose these squares into rows, and then those rows cover a rectangular region, right? Later in middle school, they can start seeing, well, how do I solve this? Well, I can decompose it into this, or hey, draw a rectangle around it. And then I know that this little piece has to be subtracted from the rectangles area and the like. Higher, if they want to know why 1/2 base times height is the area of a triangle, they might cut the triangle in half and put it together. So now you got height and half of the base. Oh, that makes sense. Or you might say, well, what if I had 2 of those triangles? It's 1/2 the area for one of those triangles. Geometric thinking makes things like the formulas for area real. And that goes all the way up to problem solving and even calculus. I didn't get a chance, because I'm pretty well out of time here, I didn't get a chance to tell you about our website that has all these levels and activities with PDFs for free and everything at learningtrajectories.org. So you can quick snap a picture of that if you want to. That will take you there. But really, it's just almost just as easy to just say learningtrajectories.org. You click on Explore LTs and you go to Geometry, Shapes, or, because I ended with that, Composing 2D Shapes. And there is also a 3D shape for, and I can't remember your name, I'm so sorry, the person that asked about spheres, balls, and circles. There's information about those and the like. So we are working on another project called Bajillions. If you ever want to join a project in its very early stages and try out some of our software, and it's integrated with learningtrajectories.org, and I can't show you all the slides I was going to show you with this because I'm pretty well out of time. I wanted to end up with anybody who I haven't yet convinced. Did I draw this on the screen? Oh my gosh. No, clear all drawings. Yeah, I did. I don't know how I did that. Sorry about that little curve there I had on the screen. Anybody who still wants to be convinced, I will end. I got 3 minutes only, so I'm going to go fast here. That mathematizing for preschool goes way back to Frederick Froebel, the inventor of kindergarten and Montessori. Because look at Froebel. Look at his famous gifts and occupations. They are about shape and composing shape. So kids got a sheet like this of paper, seriously, and their tables were marked out in these little squares, and they had to recreate these with manipulatives. And so what's fascinating is look at these two and try to guess which one is by the famous artist Piet Mondrian and which one is from a kindergartner. This one's the Mondrian, that one's the kindergartner. How did the kindergartner make that in a Froebelian kindergarten? Strips of paper. The cool thing is, whoops, is this another Mondrian? No, this is a Paul Klee, but I'll do it. So which one's Gladys, a 4-year-old, Irma, another 4-year-old, and Paul Klee? This one's Crawford, this one's them, and that's Klee over there. People, the most important message I'm trying to say is Paul Klee and Piet Mondrian spent a year in a Froebelian kindergarten doing those geometry composition tasks I just showed you. It influenced their artwork. And the last you can guess which one's the Mondrian and that one's still and all. It's fun to see what was that kindergartner doing. They had paper with holes in it, and you threaded a needle with black thread in and out of the holes. Mondrian spent a year in a Froebelian kindergarten doing this and created that. Last, Frank Lloyd Wright did this for 2 years in a Froebelian kindergarten and created this, his Price Tower. Remarkable similarity, right? He did this gift, build a house from blocks, and he created this, the Robbie House. So, solving problems with intentional teaching. In his memoirs, Frank Lloyd Wright claimed kindergarten was the only definite influence on him becoming an architect. The smooth, shapely maple blocks with which to build, the sense of which never afterwards leaves the singer, form became feeling. And also the stones in my hand and under my eyes turned to living, speaking forms. That's what early geometry can do for kids. Life-altering things. Now, these are special cases, but it helps all kids learn better mathematics. So I don't see any more questions. Because I wasn't scrolling correctly. We've got at least one. What are some mathematical concepts that are not skipped in the learning must not be skipped? Count verbally in sequence and match objects one to one. Right. Actually, I will have to get together with Karen and do a different one on just that question because it has a deeper answer than I can answer right now. So wonderful to be with you guys. It was just so delightful. I hope it's hard to tell when people don't have their cameras on if they're bored to tears by what I'm saying. I hope it wasn't too bad, and I hope you had a good time. And I thank you so much for coming and spending some time with me.